The next speaker took a really, really long way to be here, and I really appreciate that, and it's really worth the journey, I hope so. So we are talking about from concept to production, reshaping design and manufacturing in the era of AI, and we are talking about a company that is quite important, I think, for the whole industry, and that's Autodesk. So we want to see how the path from idea to production is reshaped in the era of artificial intelligence. We just had a chat right up front, the speech, and I tell you, it's super amazing. So I'm delighted to welcome in on stage, so please give a warm applause to Stephen Hooper, Vice President for Design and Manufacturing Product Development at Autodesk. And please, before you give the applause, don't forget to ask many questions about Slido, because he's going to do a speech, and afterwards I get the chance to ask all my questions I have, and there are quite a lot, but please join me in asking questions using Slido. So a big applause. So Stephen, please. Stephen, stage is yours.
Thank you. First of all, thank you to all of you for being here today. It's a pleasure to come here to EMO and to speak to all of you. Also, Renee, fantastic speech. Many of you probably won't know, but Autodesk has actually done a lot of work with MX 3D. So if you're ever in Amsterdam, you get a chance, there's a full 3D printed bridge that was done as a collaboration between our companies. And it's a great example of DED manufacturing in the public world. So this morning, I have a couple of objectives. First of all, I want to introduce you to some of our manufacturing technology. But I also, more importantly, want to take you on a little journey to show and demonstrate what we're doing to apply AI in manufacturing pragmatically. So I have some physical examples that I can show you, which will hopefully demonstrate why we think AI is going to be so transformative in our industry. Now, before I get into that, many of you probably don't know Autodesk. We operate across a range of different industries, which makes us pretty unique as a software vendor. So as you can see, we're responsible for a lot of technology in the built environment. So you may have heard of products like Revit or Civil 3D. Those are for our AEC, or architecture, engineering, and construction industries. We also have software and technology for films, games, and TV, as well as the group that I'm responsible for, which is our product design and manufacturing solutions. Now, you might ask yourself, why is that important? Well, particularly here today, a factory environment is probably the best example of convergence between industries. And we actually think that convergence itself is a very important topic. If you think about a factory line, it is a unique blend of civil engineering for land development, the building shell, building engineering for the civils, the structural steelwork, the building supply for energy, water, pneumatics, and then it has the manufacturing production technology in it. So if you want to build a complete digital twin, you really need to be able to represent both that built environment and the manufacturing processing line. And so we think about convergence in three different ways. The first is the convergence between design and manufacturing. If you want to optimize for productivity and you want to increase your margins, reduce your manufacturing costs, you really need to understand the manufacturing process that's going to be employed when you design, so you can optimize designs for production. If you want to build a digital twin of your factory, first you need to converge the worlds of construction and manufacturing. And then lastly, you need to have a convergence between the digital and the physical environment so that you can actually control your factory from a digital twin. And we know this because we actually operate our own factories. What you can see behind me is our manufacturing facility in Birmingham. And so as a software company, it may seem a little unusual to run a manufacturing facility, but our belief is that it helps us empathize properly with our customers. It helps us employ technology physically in the manufacturing process. And we actually do production work on behalf of customers because we believe it's the best way to understand our customers' pain points, but also to test our software. And when we do that, we see three critical challenges that our customers face. The first is a skills shortage. So globally, it's estimated that by 2028, there will be 2.4 million unfilled manufacturing jobs. And in Germany alone, there'll be 130,000 unfilled manufacturing jobs. we actually ran some independent analysis on this, and 61% of German organizations see this skills shortage gap as potentially the biggest thing holding them back from growth. So that's a big problem for German manufacturing today. As are rising costs, you think about disruptions to the global supply chain, tariffs. These create issues with supply chain costs, but they also create supply chain disruptions. And so these are some of the major macroeconomic topics that we aim to address. And we think technology plays a big role in addressing them. Firstly, for the skills shortage, we believe that tools like generative AI can help lower the barrier to entry. When we think about rising costs, a fully digitized process that integrates your design and all forms of manufacturing through to production can help you lower productivity. The third is connected supply chains. So leveraging the cloud and machine learning to be able to optimize your supply chains and get real-time costing. Now that relies on a certain level of convergence between these technologies, and traditionally we found in our industry that tools are kind of categorized or siloed into things like computer-aided design, computer-aided engineering, computer-aided manufacturing, or product lifecycle management. And that makes it difficult to automate the process. So we think there's a period of disruption in which these tools will converge together. Now, what that does for you is it means that you can start to converge the design and make process. You can't automate what you can't model in software today together with a single process. The second thing is that it enables us to converge all of the data that represents not only your design process, but your manufacturing processes. And once you've done that, you can then start to automate processes. And that's where we can start to deliver big productivity gains. And so we look at a manufacturer's overall design and manufacturing process, and we start to analyze where manufacturers are losing time due to mundane everyday tasks where they're pretty much having to recreate information. So if you take an average engineer, for example, and this is an external study that we commissioned by an independent analyst, on average, they find that nearly half of engineering time is dedicated to 2D documentation. So imagine that. For every engineer that you have, they're spending half their time reproducing information from a 3D model to just document it in 2D. If we could give you back just 10% of that time, it would be a huge productivity benefit for your organization. The average machinist spends a day a week programming. So that's a day a week of unproductive time. And one of the things that fascinates me is the number of companies that actually re-engineer or source the same component multiple times from different suppliers. I know of one manufacturer that actually outsourced the manufacture of a set screw 27 times globally and estimated that it cost them over $2 million unnecessarily every year in supply chain. So these are some of the problems that we think that AI can help you solve. So I had a few examples to actually make this tangible so you could see some of the developments in technology. Now, this first example looks at that problem of identifying components that you've already got in your inventory and trying to standardize your designs. So what you will see in this video is an air fryer. It's a standard consumer product. Now, you can imagine when you design a product like this, there are a number of different components you use. You can use AI to catalog all the components in your cloud data storage. And then what you can do is for the dials on the top here, you can say, find me all the similar parts that I already sourced, that are already in my PLM system. And then just replace those components that I've designed with the standard components that my company already sources and stocks. And so you can actually reduce the amount of inventory that you're carrying inside of your PLM system, reduce the number of suppliers that you're outsourcing to. So simple productivity benefit, but it means that you can dramatically lower the amount of cost that you're carrying in inventory. Now, I mentioned productivity and engineering drawings. Here's just a trunnion from a CNC machine. Now, typically, this is something that when we document, we have to produce individual drawings for each component in this assembly. And there's something like 24 different components here. Now, typically in a 3D modeling system, a production engineer who's creating jigs or fixtures would create drawings, lay them out, and then they'd have to document or annotate them manually. Here you can see that we'll apply AI, and just with one click, we'll generate a number of different options to fully annotate and lay this document out. But because we're performing these calculations in the cloud, we don't just document one drawing, we document all 24 drawings simultaneously so that the engineer can spend their time focused on the jigs and fixture design and not having to sit there repetitively creating 2D drawings, which is it's a valuable output, but it's very mundane work for an engineer to have to continually just create those 2D drawings. So this means that you produce the 3D model once, all your documentation is created for you automatically. Now, another thing that you will have probably heard a lot about is large language models and what we call agentic AI. It's difficult to find a software vendor that isn't talking about this at the moment. So I wanted to give you a very practical example of how you can apply this in manufacturing. And we are here today to talk about production. So let me show you an example of a mold tool here from the same consumer product. What you'll see on the right of the screen is a agentic AI prompt, which enables you to ask questions of the system. So you could ask, in this case, what should I be using to rough this part out? And once you've asked that question and got an answer, you can actually tell it to generate the roughing strategy for you. And we will actually go and create the machining strategies without you having to sit there and pick the faces individually, choose the datums. And because it's AI generated, we have also integrated full GPU simulations so that you can actually go and test those machining strategies before you post them and put them to your machine. So this is a very simple example of where you can just apply a roughing strategy using a large language model. In the back end, we have some very specific large models, foundation models that are built specifically around machining and manufacturing data that we've worked with our partners to develop. So I can show you a slightly more sophisticated example with one of those partners. This comes from a company called Cloud NC, who partners with us. In this case, we can choose the part and automate the production of the soft draws. If we choose the raw material that we're working with, the machining center and the tooling library that we want to apply, Cloud NC's add-in will then go and produce all of the machining strategies necessary to manufacture that part. And you'll see here in this example, this is a lot more sophisticated. You'll see a number of machining strategies in the browser, which we can then go and simulate. So you can see the roughing here, and then the finishing passes in green. So you'll see it quickly go through the simulation. But we may also want to optimize the cutting parameters. So again, we've trained on the cutting parameters, which enables us to take the speeds and feeds and then optimize. Do we want to maintain reduce tool wear and maintain tool life? Or do we want to cut this part as fast as possible? And you'll see that where we plot in red, we're likely to wear the tool or break the tool. Green is the optimum cutting path. And then we can apply those parameters and actually go and machine that part down on our shop. So that's a good example of time saving on automating CNC machining strategies. Now, all of those strategies are native strategies. You can go back in there, fine tune them and edit them. But this dramatically speeds up the amount of, or reduces the amount of time production engineers have to spend producing this type of data. Now, the last example I want to show you is a graphing environment. This is for building systems automation inside of Fusion. This enables us to take CAD geometry, and remember I said the convergence between the design and manufacturing is important. We can take the CAD geometry and we can use it to do feature recognition, map that feature recognition to tool selection from our tooling library, and then process the machining strategies. And so this builds a template, a pattern for machining this part where we recognize the pockets and the holes and we can machine it. But because we have that pattern, we're now able to apply the same pattern to any part that's similar. So we never have to program the same type of part again. We can just apply the same machining pattern to job after job after job. We can also integrate third parties like Toolpath for machine tool quotation. So we can actually analyze the part, the machine strategy, look at the timing for the part, build a cost, and then bring the cost back into our bill of materials. And that's important because as we start to move supply chains around globally, we need to understand the costs that we'll incur by outsourcing manufacturing to different areas of the world as we try to optimize the cost. And so this is something that's very important for people when they're moving factories globally. You'll see that there's a lot of inefficiencies in factory deployment globally. 60% of manufacturers miss deadlines, which means that they're misallocating capital allocation. And that means that they're making poor choices about investment with their capital. And 72% of projects are exceeding budget. The crazy thing is that 70% of manufacturers are still using spreadsheets in order to design their manufacturing processes. And we think that this creates a lot of inefficiency in the production process. And that actually starts with the development of the plant itself. So typically a manufacturer with a greenfield site will go through a process of planning, designing, building, and then operating a manufacturing facility. And at each point in that process, they're introducing a lot of inefficiency because as they hand data from a civil engineer across to a building engineer and then on to production and planning, they're losing information at each stage of that process. And then worse still, when they get to operations, they have a static level of operational efficiency. So our belief is that we need to streamline that process. And again, this is another form of convergence where we're bringing together building engineering, civil engineering, and production process planning together in a single digital model so that we can see that information flow freely and smoothly across the process. But we also want to empower manufacturers to continuously optimize their factory facility. So we're analyzing the production process efficiency, using those statistics to then re-engineer the manufacturing process line to continually improve productivity. So I wanted to give you another example of what this looks like. So in this particular example, what you'll see is a manufacturing facility that's been designed. The production process has been laid out using our discrete event simulation technology. Those times, processing times, the flow times, are all derived from estimated times. And that enables us to model out the production process and then speed up time and look at the production process efficiency. But remember, those are estimated times. So we also have a manufacturing execution system capability that's linked to that discrete event simulation, which means that operators on the shop floor are getting their manufacturing instructions, but recording the times. And those times can then be imported and used to develop the statistics that are then powering our discrete event simulation. So rather than using estimated times, we're actually reclaiming information back and empowering that to update our simulation so that we can be continually optimizing the manufacturing process to get the best production process efficiency. And you can see there's often a big difference between the estimated production flow times and those of the actual flow times on your shop floor. And our belief is that what we can do is, rather than giving you different products to manage this process, one for architecture and building, another for production process or discrete event simulation, we can converge these technologies on a single cloud industry platform that enables you to build a full digital twin of your manufacturing facility so that you can make more informed decisions at the architecture, planning, and build stage of a greenfield site development. But you can also control that manufacturing facility and continually improve its efficiency when you go through brownfield site development. That leads us on to the last part of that process, which is where we can start to use generative AI again to look at things like generative layout for a production process. If you know the cycle times for each operation, you know the arrival times of raw material or inventory, you can then start to generatively lay out and optimize the manufacturing process within the building shell that you have. And that's where we see the future, is in applying these AI technologies to help optimize the production process continually so that you end up with a digital twin that doesn't just simulate or observe what's happening on your shop floor. It actually optimizes and adapts your manufacturing operations so that you have continual improvement in your operational efficiency. So I think what I would leave you with is that the rate of change due to AI is growing at an exponential rate. I mean, 2 years ago, I'm guessing most of you in this audience probably weren't using ChatGPT. Most people would have said 2 years ago that AI was a long way away from disrupting any of our industries. Most of you have probably heard of Moore's law when it comes to microprocessing technology, which says, processing doubles in capacity once every 18 months. I would argue that AI is doubling nearly every 6 to 9 months. Its rate of growth is exponential. And that's why we've invested so much in this. We have over 90 research papers published in this area of computing science because we think it's going to have a dramatic effect on the production process. And, a lot of people viewed this as a threat to employment. But as I mentioned earlier, when you think about the fact that in 2028, there'll be 2.4 million unfilled manufacturing jobs, I would argue it's a necessity. It's not going to put people out of work. This was the old view. I think what it's going to do is going to keep the same amount of people employed and fill the skills gap that we have as we move into the future. And what I would hope is that it will introduce greater innovation at the front end of the design and production engineering process. It will help improve quality. And overall, it should help all of you make more profit in your business. And that's why we think that AI in the manufacturing process is something that shouldn't be ignored. It's something you should be investing in actively now. So with that, thank you for your attention. And I think we will move across to our Q&A session.
Thank you so much, Stephen. Let's have a seat. It was awesome.
You want to sit or? Okay.
Yeah. Let's have a seat. So this is your chance, by the way, if you want to interrupt me in our conversation to ask questions. There's already the first, but first let's start a little bit into feedback to the presentation, what we have just seen. The first question that came into my mind when you presented the opportunity of optimizing parts. Let's stay first with a part before we step into the convergence. So what I would be afraid of as a supplier of parts when I'm using your solution, and I know you have all the data in the background, so that probably once I start optimizing, everybody else could use the same optimization as well. How do you see that?
What happens if you're the one that doesn't use it?
Pretty true. That's a good one.
Yeah, I think this is the thing is people always look at new technology development as a threat. So you could go right back to the Industrial Revolution, and there were people that were trying to destroy machines because they felt they were a threat to their job. I would say that the GDP globally has done nothing but increase ever since. And so I actually think that new technologies are an enabler, a catalyst for improved quality of life. And I think all that happens is that innovation and your ability to competitively differentiate in the market just moves to something else. And I think eventually that, everyone will catch up with that technology. And you've heard, you've heard the phrase that you can't stand still or the world moves around you. I think this is absolutely true here. Unless you embrace this technology, your competitors will, and you'll be at a disadvantage. I think the opportunities to embrace the technology before your competitors do, it's like being first to market. If you're first to deployment of this technology, you will gain an advantage. Even if that advantage is only temporary, it's often enough to build a moat around your business that your competitors then find difficult
to be ahead, basically. Yeah. True. So, we have talking about the convergence. Can you share a real example of convergence where I connect factory and machines?
Look at this facility. This facility is a perfect example. So there are many of our machine tool partners here, from DMG and Matsuura to Mazak and Haas. Every one of them's had to set up a machine in this building. Every one of them will need power supply to that machine. How do you forecast where that power supply needs to be, what the draw on energy will be to run this show? You need a building model to help you understand where all of the structural steel work is, where the lighting is to set this stage up. That's a perfect form of convergence. If you don't understand where the power supply is, what the energy consumption requirement is to run these machines, you'll end up bringing a multi-million-dollar machine here. You will sink the bolts in the ground, set it up, and then you won't be able to run it. Yeah. And every day that you can't run that machine here at this show is a day where you're losing potential sales. And so that's a perfect example where convergence is absolutely vital. I think Renee from MX3D shared some examples earlier on as well. When you look at running a manufacturing facility, often parts break. And sometimes those parts, due to logistics, have months before you can actually replace the part. So we often find a lot of our customers, another form of convergence is being able to digitally scan the environment and then on-demand manufacture there on site. Even if it's only a temporary part until you can ship a full replacement part out. Again, if you bring a production line down for a week, that's costing you millions of dollars. So that's another form, I would say, of convergence.
Probably, I'm not too much into the industry to understand, but what I was really surprised of was the fact that you're not only looking at the beginning of a design or idea process, you have the overview, let's say, of the whole production cycle.
Yes.
Basically, that's what I saw in your solution.
Yeah, absolutely.
So my question is, at the very beginning of your presentation, you mentioned that you try out yourself and you have your own production facilities to see it in real life. But where comes all the knowledge from? I mean, we have so many different industries where your product has been used, so many different options, let's say, but you still have to think till the very end in order to offer the right solutions, right? Where comes all the knowledge from?
So we try to make sure that we employ industry experts. So we have a mixture of computing science professionals and industry experts. So for me personally, I came from industry. I was a production engineer. Many of my colleagues are ex-manufacturing experts. Most of us then go back to school and learn computing science. So we bring a certain amount of domain expertise with us, but obviously you can only cover so much. So our manufacturing facility, we actually employ production engineers and machinists there. Their job is full-time manufacturing. They don't develop software, they run machines. And so we do contract work for customers, not because we make money, but because it gives us an appreciation for the process. Again, we can't cover every process. So what we also do is we have customer advisory boards. In fact, we have we call it a Friday morning meetup. And so we have about 200 customers that join that call every week. And we run it on Zoom. We often have customers that just come and share what they're doing. And everyone from small machine shops who are just startup businesses to large manufacturers. We have the guys from Meta that are using Fusion to machine the VR devices. So we'll have people from every sort of industry come and share their experience. So that's another source of information. And then, of course, our user experience experts work out in the field. So we love partnering with customers. We actually partner with folks like Iskar, Kennametal, some of the tooling manufacturers. We find that working with them also is a great source of information. So we try and stay as close to customers as possible. My favorite part of my job is being here, visiting customers, understanding what they're doing, seeing what partners are working on. I get a lot of energy from that.
And connect the dots, basically, to come back to your software. Great. So you're coming just from Nashville, AU, a big event, I think, for you.
They probably don't know what AU is.
Autodesk University, where you present all the new solutions.
Yeah.
What was the reaction and what were the key highlights that you took with you?
I think most of the reaction is to the AI technology. There's a lot of hype around AI. So you won't find a software, let's be honest, you won't find a software company that isn't trying to tell you that AI is why you should work with them. Our belief is that practical demonstration of the technology is what differentiates us. So you asked me what happens if everyone else adopts the technology. Isn't everyone on the level playing field? And I said, the most important thing is to get to market first. We have the same problem. So when we build software, our competitors are also using AI. So we ourselves face the same challenge. And our belief is getting to market first is what differentiates you, which is why we took the decision to not show, I showed you videos this morning, but last week we were showing live demonstrations because we want our customers to see that this isn't just a PowerPoint, it's real technology that you can use today. And so that was probably the biggest buzz. Also, I would say a lot of folks, they use tools like ChatGPT. And you've probably all used it, right? It's great, but it gives you kind of, it gives you vague answers. Sometimes the answers aren't accurate. So there are some machine learning technologies you can combine with large language models. So large language models are very good at understanding your question and interpreting it. But then what you can do is you can use a process called Retrieved Augmented Generative Results, RAG. And what a RAG machine model does is it actually uses an accurate database of information so that the results that you get are precise results, not interpretive. So those precise results mean that you can use it for engineering applications like CNC machining, which you couldn't use a pure LLM model for. So this combination of leveraging LLM for the natural language input, but then converting it to a precise deterministic output that you can use for engineering, I think is really capturing people's attention, because I think most people thought, these generative models are good for image creation, but I'm an engineer. I need precision. I can't trust non-deterministic output to run my machine tool. So this is where we start to see the boundaries being crossed.
Before we step into the questions, just two more from my side, and then I promise I answer your question here as well. I'm a lot, as you are, in touch with the industry, talk to them. There's a lot of skepticism, and I think you tackled a very important point. Most of them know ChatGPT.
Yeah.
So they work with ChatGPT, and there you come to the point where you need precision, and there is no precision, because that's not what the model is intended to do, basically, right? So what do you do with the skeptics? So how do you talk to them? Because
to show them.
I tell you, especially here in Germany, that's my experience, due to our or being afraid of losing data and public, I think a lot of hindrance in order to use it, basically. So what do you tell them, beside the story you need to be first, because there's still a lot of skepticism?
So two things I would say is, first of all, there needs to be trust, and then there needs to be demand. So you'd be the same with your own customers. Like when you manufacture parts and sell them to your customers, first of all, there has to be demand. Your customer needs to have a requirement for those parts, and you have to be a cost-effective supplier. And then secondly, there has to be trust. They have to believe that you can manufacture those parts on time with the quality that they expect. And the same thing's true for us. So I think to build the trust, first of all, you need to show people the technology. So demonstrate it. Don't just talk about it, demonstrate it. And then secondly, there has to be the demand. And I think I illustrated that most of you probably feel this problem already. It's hard to get skilled engineers. They cost a lot of money. And there aren't enough of them coming out of college now to fill all the jobs that are there. So I think that those are the 2 points that I talk to most customers about, is to help them understand that there is this problem that they perceive. How can the technology help them address that problem, and then help them understand that they can trust that technology? I will say the technology is not perfect yet, which is why we have a very strong belief that we have to create editable geometry or editable manufacturing instructions. And the analogy I would give you is a bit like self-driving cars, right? Everyone wants a full self-driving car. I would love one. There are companies that claim to have full self-driving cars. Do you trust them enough that you would buy a car without a steering wheel? I suspect you
probably not yet.
You want a steering wheel.
Yeah.
You want the steering wheel for two reasons. One, you don't 100% trust that it will get it right every time. And secondly, you probably enjoy driving. So you want to drive when you want to drive. And I think the same thing's true with the software. You want it to be able to automate tasks, but you also want the control to ensure that it meets your standards. And secondly, you probably enjoy the work that you do. And we don't want to take that away from people. We just want to help them automate the processes that are mundane so they can focus on the processes that earn them money and help them differentiate.
Let's take a little bit of a look into the future. I mean, you have on the last slide the development and how fast it is.
Yeah.
Whatever I hear is like it's really overproportional fast than we can imagine, let's put it that way. So where do you see the whole topic of AI in 5 years, let's say?
So there was a question about AGI, artificial general intelligence, which is, people would say that's when it's indistinguishable from a human being. And then there's super intelligence, which is when it's actually better than a human being. It's impossible to predict when that will happen. What I will say is that typically people overestimate what is possible in 2 years and drastically underestimate what's going to happen in 10 years. So again, it's impossible. My gut says 4 years, maybe 5 years. But look at the rate of development. It's incredible. What these models can do now is unbelievable. And that's just in the last 18 months that's happened. That's why I say I think it makes Moore's law look pretty slow by comparison. So I think it's very hard to estimate with certainty. I think the other thing that people have almost forgotten about is quantum computing. And again, quantum computing is a thing where people say, oh, it's 10 years away. That's what everyone said about AI 3 years ago. And I think when you see quantum computing and AI come together, then things will really take off.
Yeah. I can pick up one of the questions because it's really touching their point again. So let's talk about the beginning, the stepping in. We were talking about skepticism on the one side, speed of development on the other side. So let's say I'm a small company, I want to step in. Would you consider, and here the question is, start with something like ChatGPT to learn and understand? And because, I mean, considering fusion, for example, the small company might consider it as a big solution in this point. How to step in? Because that's another point regarding the skepticism. The first thing is you don't know enough about it. Yeah. Then you are a classic engineer, you want to step in, and then, of course, you see the long learning path to step into it. What would you recommend?
I think the first place I would start is using it as using AI as an advisor. You know, I often use it to speed up things that I'd probably do myself manually, but it can do it for me faster so I can focus on something else. A good example is research. I have to do a lot of research, like market research. So I use Microsoft's Copilot has an agent specifically for research. So I was doing some research on plastic injection molding, like market demand for plastic injection molding, which industry subsegments, you know, which countries globally. It was able to do, I think, about 20 pages of research in about, I don't know, 10 minutes, which would have taken me a week easily. Sometimes I'm looking at other companies and I want to know what the company size is, who the CEO is, where they're based. You can get it to do a bunch of research. Now, the thing about that is it helps build trust, because you get that research and eventually you validate it and you realize that it's actually pretty trustworthy. And then you start to, the more you trust it, the more you start to rely on it to actually produce things for you. So maybe you're going to rely on it to produce a document for you that you would then use. I think the same thing's true with what I showed. You know, that example for machining, you can ask it to give you some recommendations on speeds and feeds. Now, if you're a machinist, you know whether what it's telling you is accurate or not. You have a good feel for that. If you find that 99.9% of the time it's giving you pretty good, reliable advice, you're probably then going to start to trust it to create strategies for you. So I think you just progressively adopt it.
And this is probably the point where you still keep your steering wheel, but you say, I
used it in drawings. So I often, because I still use software myself. So if I was creating like a drawing for a fixture, I would use it for the annotations. And I'd still, to this day, it's not perfect. I mean, sometimes you'll get leader lines crossing text dimensions and stuff. So I have to make some corrections, but does it speed up my work? Yeah. I mean, I probably spend only 20% of the time I would have done creating a drawing. So those are good places to start, I think.
Yeah. Here's a very interesting question that comes from the other end, basically. Do you see AI agents capable of doing design reviews at some stage? Or probably there is already.
Design reviews?
Yeah.
Yeah. So I've been working with there's an AI called Claude that's made by a company called Anthropic. And it's optimized very well for software development. But because it's optimized for software development, it's able to build systems models. And so I had it do a review of a consumer product, because we were working on that air fryer as an example. I had it do a review of the product, and it was able to make material recommendations for me and surface finish recommendations on the heating elements and the tray drawer for the thermal conductivity. It was able to tell me what its recommendation on the pitch was for the perforations in the sheet metal plate, what material I should use, and the finish. And we validated it. It's 'cause, again, not 100% trusting it, It was absolutely accurate. So yeah, I think it's at the point where you can use it as a first pass. So we often do this with simulation. There's a different branch of machine learning called surrogate modeling. It's not generative AI. What it does is it takes empirical data, and that machine learning model can forecast a result based on historical data. So you give it 1,000 CFD analysis results, and then you give it a new shape, it can predict the flow for the new shape based on the old results. We find that that's not 100% accurate. It's maybe 85%. But if you're designing, it's good enough to get you in the right ballpark, so you can then use traditional CFD solvers to perfect the simulation results. So again, I think it's at the point where for early stage design reviews, it's pretty usable.
What I really saw as an advantage, that's what I want to tackle as well, because that's something that appears to me very often when we talk about additive manufacturing, because this is one of the main advantages here. You mentioned the air fryer and the knots on the top, yeah? And you said check the part if it's already there.
Yes.
So basically, in the future, if we think about a digital warehouse that we might have, or that some of the companies already have, it will really save a huge amount of cost there, because I do not have to develop parts 10 times for each and every product I'm doing. I really look, what can I reuse, which is a very standard procedure in automotive, where you see like 5 different brands and all have the same knob here.
I can give you a really simple example. Like where I used to work, nobody stocks every size of fixing, right? So maybe you stock M4, M6, M10, 12, M16, M24. You don't use an M5 or an M7. And they come in maybe 5 lengths. So when you're designing, you make sure you're using those fixings, even if they're not perfectly optimized, because you know it's going to save you cost in inventory. So the example I showed wasn't a great example. What you really want to do is take a fixture that's got like 1,000 fittings in it and ask it to optimize based on what you stock in your inventory. It's such a simple thing, but it takes engineers hours to sit there and do it. And if they don't do it, you end up stocking every size of every fitting. Same thing with machine tools. In our shop in Birmingham, every machinist will pick their own machine tool. You know, like we'll stock basically every size of end mill that you can imagine. So just being able to optimize what you're using in your machine tool library, that's another example where it's a super simple usage, but it can save so much money. That's why I think when people worry that generative AI is going to put humans out of work, I don't think it's going to put anyone out of work. I think it's just going to change what you do at work, and it's probably going to make your job more enjoyable.
Yeah, and on the other side, as I see, we already have today such a lack of skilled labor. I mean, once we fill that gap, we can think about losing jobs. And that,
you know, there's a perfect example of this that happened in a different industry about 30 years ago. So when I used to live in the UK, Fleet Street in London was where every newspaper was printed and then distributed. And then the desktop publishing revolution happened. So everyone remembers what you see is what you get, WYSIWYG. Before that, you had typesetters, print setters, print operators, editors, graphic artists. They were all separate, using their own technologies. And then desktop publishing happened, and on a single platform, on a Windows machine or an Apple Mac, you could create a publication and then just print it. And I'll say that when that happened, it put a lot of people in Fleet Street out of work within the first year or two. After that, you saw this proliferation of different publishing houses start independently across the country. And now there are many, many more people, millions of people employed in technical publications where they couldn't before, because you could only afford to print media if you could amortize the costs over a single production facility. And it's kind of the same thing in manufacturing. When you democratize the technology, there's an initial shock. After that, you start to see a proliferation of the technology and many, many more jobs created.
And I even assume that even if you withstand the technology improvement, you say, I don't want to have anything to do with that, it might bring you to another level, because after that you have to adapt and have to step in.
Then you're behind, right?
It's already, I think it even affects our mindset at a certain point, especially the elder generation.
So there's a book that I think everyone should read. It's called The Innovator's Dilemma, and it's written by a guy called Clayton Christensen. And he talks about how disruption comes from the bottom end of the market. So one of the examples he uses is hard drive manufacturers. So everyone used to make hard drives for computers, spin drives. And when you remember memory sticks, when they first came out, thumb drive, they could only hold about 5 megabytes, enough for maybe a presentation or a Word document. And so all the hard drive manufacturers just said, they just ignored it. That's never going to. So then these thumb drives then got bigger and bigger, 500 megabytes, then a terabyte, and then they got faster and faster. So now you have solid state drives. And as soon as a solid state drive was able to do as much as a hard drive, it almost immediately put them all out of business because they didn't see the disruption coming. And it's happened to so many companies. Think of Kodak. Kodak was working on digital photography before anyone else, but they didn't see it coming, and they wanted to protect their business. They tried to stay where they were, and it put them out of business. And I think this is the problem, is that most people look at these new technologies and they underestimate what they're going to be able to do. And these technologies grow and grow, and then if you're not careful, by the time they're able to do what you do, they put you out of business. So this is why my message is, try to adopt this stuff as fast as you can.
The funny thing is there are endless examples. I mean, this is something we can really discuss hours. That's crazy. So then let's do another look in the future. I mean, I see the speed of adoption in the industry, and I see the speed of development that we just discussed. And that doesn't fit together, you know what I mean? So I see the speed of adoption is here and the speed of development is here. So how do you see, how can we close this gap? So how do we get the industry adopting faster in using AI? Because then we have generative AI already everywhere, but nobody's using it, or not in the terms it should be used.
So I actually think that the AI is the answer itself to that question. So like, I told you, I used to be a mechanical engineer. So I worked in production engineering, used to do jigs and fixtures and sheet metal production. So when I left to join Autodesk, I didn't have any software education. I had to go back to school and learn it. Recently, because I haven't done any coding for a while, and there's a lot of languages, I don't know them all. So I was doing some coding recently with Python. I was trying to write an add-in to do some stuff in Fusion. So I used a tool called Replit. So Replit is a generative AI tool that will build code for you, but it will also teach you what it's doing. So it has what we call reasoning. So as you ask it questions and you ask it to do things, it tells you what it's thinking about and how it's doing it. And I found that invaluable because it actually teaches you as it's doing it with you. So there is this thing called, it's a trendy term at the moment, called vibe coding. And what it means is that you don't just ask the AI to do something, it goes in a black box and does it for you. You have this two-way relationship. So you're asking it to do stuff, it tells you what it's thinking about, it gives you a result, it's not perfect, so then you tell it to edit it, you tell it what to tweak. I think that's the answer, because I think that helps you adopt this technology faster and faster because you're working with it and it's educating you. And this is where I think large language models are beneficial because they can help you understand and they can teach you. It's like having a, that's why they call it co-pilot. It's like having a co-pilot with you. You know, we watched the Marvel films with Jarvis. It's like having Jarvis with you. It's not going to, it's going to sit there next to you and help you. That's where I think it's not like traditional automation technologies where you employ a consultant to come in, you tell the consultant what you want, they go away, they build it, and they bring it back. And the problem with that is that if you want to change it, you then have to pay the consultant to come back and redo it. I think the thing with generative AI is it can work with you and co-author.
You're growing together.
And you grow together, yeah.
Funny that you mentioned Jarvis, because there's a question, how do you imagine the super intelligence AI, which probably is the future we're all afraid of, at least the ones that have watched the movies of Terminator. So the question here is really, I personally imagine, let me imagine my future, So I have no technical background. So, and I have the imagination that at a certain point, I came up with an idea, like probably every one of us, like inventing the hoverboard, like in Back to the Future. Yeah. So I invented, and instead of having to use like several engineers that help me out, etc., I'm able to do it myself. Not only doing myself, setting up a production, finding the right materials, etc. Could that be the future?
I think so. So the sort of frontier at the moment is true creativity. So what you'll find is that with a lot of generative AI technologies today, I won't go into all the details of how they work, but they decompose text. They use a process called labeling. They encode it in a database, and then they can decode it, which creates something new. But it's actually a recomposition of a lot of existing data. So when we train a model, we're training on a lot of existing data, and then it can recomposite that information into something new. Right now, we still haven't had an AI create a new branch of mathematics or a new branch of chemistry or develop some new material or new manufacturing process. It's usually creating something for you that's already been done, but applying it to a new part or a new process or leveraging some mathematical formula and applying it for you. As yet, AI hasn't discovered a new branch of mathematics or a new branch of science. That, for me, is where that super intelligence will start to come, when it can actually start to push the boundaries of human knowledge and discover new branches of science for us. I think that's when it will get really interesting. There are other industries in which you see this happening. So microprocessors, microchips are so complex that humans don't design them anymore. There's way too many transistors on a CPU now for a human to actually manually design them. They're produced with a process called synthesis, which is machine design. I think that's an example for you. There's no way a human being could develop the next generation of microprocessor technology today. It has to be machine design. And I think that's what you have yet to see in the physical production process.
And in this regards, I think this might be also a solution for lack of staff, etc. Because I mean, you can do multiple things at the same time.
I think the other thing is two things. First of all, we're seeing, if you haven't heard about it, there is a new branch of computing. Well, it's not a new branch. It's called MCP. It's a model context protocol. It's a standardized instruction set that allows a large language model to control another piece of software. So Microsoft has an MCP server for Microsoft Office, which means a large language model can talk to Microsoft Office and instruct it to do something like build a PowerPoint. So most of us in the world of software are building MCP servers to control our software. So there's an MCP server for Fusion. So a large language model can control Fusion. So the first thing is, if lots of bits of software have MCP servers, a single large language model can actually control a whole process for you. The second thing is robotics. So you've seen some of the humanoid robotics now developing at a rapid rate. I think what you're doing is you're giving artificial intelligence arms and legs. So you mentioned like the Terminator thing. There will be a time in the not too distant future where we'll start to have droids that are able to do things for us. I think MCP is the software equivalent of that. You are literally giving these AIs an ability to control stuff that we today have to manually control. And I think that's where things will get very interesting.
Let's end up a little bit. You have a booth here, I assume, yeah? What can we expect at Autodesk? I mean, we tackled several topics. What is going to happen at the booth, and what can the people enjoy there and get more into it?
So I think, you know, AI is a big topic. It's just one branch of computing science. Software is a tool that helps you speed up processes. So there's lots of other automation tools that are available. I showed you some of our discrete event simulation. Most people know Autodesk as the AutoCAD company. A few of us were discussing earlier that we grew up using AutoCAD.
Me too, yeah.
We do a lot more than that. So we've invested billions of dollars in our CAM. The other bit that people aren't so familiar with is our factory design and planning technologies for operations management. So my view is that this convergence brings these things together. So imagine a digital factory where you have a machine tool and operators, and you can simulate operation time because you can simulate the operator loading the machine cycle time, the process through the factory, so you can optimize inventory and processing time. Now imagine that the CAM software is linked to that, so that when you go to CAM and you change the machine cycle time and you reduce the machine cycle time from 5 minutes to 3 minutes, you can then evaluate what impact that will have on the production line, because you can update the discrete event simulation, and then you can put that into process through your MES tool. And then as that goes into process, you can start to reclaim information from the shop floor, from the telemetry, from the machines and the operators, and then bring that back in, reevaluate the process, adjust the machine cycle time in the CAM programming, and again, iteratively optimize the whole system together. That's what we want to show you on our Autodesk booth, how we can bring these technologies together, the building, the manufacturing process, the machine instructions through the CAM, and how connecting these systems together gives you continual operational efficiency. And sure, AI hopefully can help speed that process up and optimize it for you. But that's the future, I think, is this fully adaptive manufacturing process. And that's what you'll see us demonstrate on our stand.
And that was honestly for me the first time I heard that you are that wide in your perspective as Autodesk, look into every part. And this could work both ways if I understood you correctly. So let's say you save the 2 minutes in a production part, and you give it into the system. It might even come to the point where the system tells you, let's change the part a little bit, then we can even get more out of production. So it's linked all over the process. That was pretty new to me.
And the other bit I'll say is, look, as a software vendor, it'd be tempting here to sit here and say, in order to get this benefit, you need to use Autodesk software everywhere. I don't want to put you off doing that, but I do think, like I talked about this model context protocol, it gives us an opportunity to work with other vendors. So if you are using a Siemens product, or you're using a Dassault product, or a PTC product, they're competitors of ours, but if you as a customer find that to be the right solution for design or manufacturing, we can bring these tools together to give you the best process, because really, ultimately, our goal is to make our customers' lives better, to make them more profitable, more productive.
Yeah. Honestly, I'm pretty sad that we're running out of time because we are already 10 minutes over time. That's okay. We have still 4 minutes left. So we have some product.
I do want to answer that one question. Will generative AIs be part of standard subscriptions? Yes and no. So our goal is to provide as many of them as possible, but they cost money sometimes when we run them in the cloud. So you as manufacturers have raw material costs and energy costs. And so you try to calculate that cost, add a margin, and then sell that as a profit. And we do the same thing. So if we can provide it to you, and it doesn't cost us money, we will add it to a subscription. If it implies some cost for us, then of course we have to charge a little bit of money to cover the cost. But our goal is to democratize it. So as much as possible, the answer is yes, but sometimes we'll charge. So I did want to answer that because I could see.
Yeah, very good. But this is exactly what I wanted to say. There are a few product-related questions. Yeah. So that's what I saw. And this, in my opinion, is the perfect handover to your booth and your team, because I'm super sure, as far as I know, Stephen and Felix and the team behind, they're more than happy to answer you this question at their booth, because this is exactly what it's done for. So Stephen, it was more than a pleasure, to be honest, having you here, having this chat with you. I could go forever. Thank you so much. Have a great, successful visit here at the EMO. Great success for your booth and your team. And a big pleasure having you here.
Thank you.
Big applause for Stephen Huber. Ladies and gentlemen, Stephen,
thank you.
Pleasure. Thank you so much. Great.